Welcome everyone. In this video we will continue the work that we started in the previous videos. So in the previous two videos we created a software for the Arduino which is able to do a two-way communication. So we can send some data to the Arduino will process it and it will send something back. So that was the first part, and this communication was done through the terminal of the Arduino's development environment. And then I made a second video where I created my own serial terminal. So we wrote a software in Microsoft Visual Studio in C# language, and we created a serial terminal which is able to communicate with the Arduino. So we can select the Arduino from the COM ports, and then we can receive data and send data to the Arduino. And as you can see on the screen, we have the window here, and now I rearranged the windows a little bit, because the next step, as I promised, will be that we will create a chart, so or a graph where we can plot the data that is coming from the Arduino. And why is this interesting, or why is this useful? Because if we have a set of data which comes periodically from the Arduino, so let's say we read the temperature or the humidity of by a sensor, and we send these values to the computer, we can visualize these data and make some measurements. So this will be like the main moment of this video, where I show you in a few simple steps how to process the data that comes from the Arduino and how to visualize it. And also I will make a simple addition to this software where we can save the data to a text file. So that's all for now. So let's begin. So we would like to add the chart. So I created this empty area here. So we look for something which is a chart. So you can see that we just have some columns here, and there is like a series, and that's all. And here I just would like to change the name to something which is a bit more easy to recognize, or whatever. It's not really necessary, but instead of chart 1 I would like to use data chart, let's say. So this will be the chart which we will use to plot the data. So we are done with the visual part so far. In fact, we might add a checkbox for the file saving. So we add this, and we add the name like file saving checkbox, and save to file. What we will do here is that if this is checked, then the incoming data will be automatically saved into a text file. We will not take care about of the formatting of the data or everything or anything. We just channel or pipe the data straight to a text file, and that's all for now. So we are done with the visual part for real. So let's go to the programming part. What we have to know here is that we have to know the structure of our input data, right? So I just make some comments here that like this. So the structure of the input data. So if you remember from the first part of this lecture, then we made a small function in the Arduino which sends us 3 columns of data. So we have like column 1, and then there is a tabulation, and then column 2, and then there is another tabulation, column 3, and then there is a line break, and then it continues like this. So for example, it always comes like this, and then it continues, so on, so on. So we know that we would like to process this sort of data here, and we would like to be able to see the details of this data. So what we do here is basically we see that these columns are separated by tab, and we can put each fields of this line into a new variable. So first let's create the variables. So those are very simple, and for the sake of simplicity we call them split1, split2 and split3. So these are our arrays. And since this is an array, we make like this. And then we would like to put the received data into this into a variable which is again an array, and that will be a string. If you notice that this is a double because we will store numbers in it, so let's create that one as well. So that's private string, and that's also a array, and then let's call it split, and then this should be a new string and 3, and 3 because of the 3 data, call 1, call 2 and call 3. So because of call 1, 2, 3. So that's all for this part. We have to create another part for the split, because if you see that this is an array, so this will store all the parts, but we will need some temporary numbers as well, or temporary variables. But those are simply doubles again, and then let's call them split1, split2 and split3 with these underlines. So I think this is done. And why do we do this? I will show you in a second. So when we start our form, we have to initialize these arrays like split1, split2 and split3. So that is simply split1 equals new double, and then we have to give a number, let's say 1000, because that will be enough for our purpose. And of course you can say that, okay, how should we know this amount? Like, how do we know that we should write 1,000 there and not 5 or not 5,000 or 1 million. So how do we know the amount of data that we will put in our arrays? We don't know, but we can like estimate it if we know our measurement setup. Or we can make, I think it's called list or dynamic list or something like that. So you don't have to take care about the number that you put here. So the size of the array doesn't have to be determined in the beginning. So you can be dynamic, and that makes things easier. So far we are fine with this. And then we have to process the data which comes in. If you remember that so far we have this part in the processing data. So when a data comes in, then we convert it into string, and then we put it in the received data text box. So in this text box here. So we have to improve or extend this part. So first of all, split up our data. So just a reminder, our data looks something like this. Tab, core 2 and tab, and core 3 and new line. So we have this split, which is a string array. So then we want to split up the received data. So we can do like this. And here in the parentheses we can describe what kind of separator we want to split by. And here we split the data by, or separated by tabs. So in the split string we will have these 3 numbers, and we know that each split is something like this, so it has 3. That means that it should look like this. So the split column 1 and split column 2 and split column 3. And for example, this is like a split, the ith split. So each split will contain 3 data, which is the 3 columns from here. I hope it's clear enough. So now we have to put these numbers, these, into their own variables. So if you remember, then we defined these guys here, split 1, split 2, split 3 with this underline. So first we want to put them there. So we try to parse it, and then basically that the split 0, that's the first value of it, and then this should be the split 1. And then we just repeat this for the other 2. And then we just have them in a temporary variable, but they are already converted into doubles. So now we say that the split 1, which is an array, that should be this value. And here I put a counter here, So let's initialize that. Private int counter. And I will tell you why is that important. But first let me do this. So this was split 2 and split 3 and split 2 and split 3. So now maybe these two can be merged. I'm pretty sure that maybe this can go straight here and this can go straight here, but now this is how we do, so we understand it better because we decompose or divide the steps. But still we have this counter and we want to increase it. So because one data comes in, then we split it up, put it in the 0th, and then we increase the number of the counter, so the counter will be 1. The next data comes in, so then the next line of data will be split up and it will be put in the first line. And then counter is increasing, so another data comes in, we convert it, and then it goes to the second place, and so on and so on. So we have to follow this. And it's better to be safe, so let's put this in a try catch, just to be on the safe side. Perfect, but we don't put anything in the catch. And here we have to plot as well. So after we get the values, we immediately plot them. So we have the chart here, right? But we haven't done anything with it. So we have to take care of the chart as well. So we have to make a function or method to initialize the chart. So let's call it init chart, and this will be for the initialization of the chart and for the setting up the name of the axis, the auto scale, and so on and so on. And before we forget, then we should put this here, because when we start the software we should initialize the chart as well. So we are good with this, and then we can start to use some things. Actually this can be customized entirely, so you should do this for yourself. You can find the perfect documentation on the Microsoft's website. So here I just share some stuff that I personally do. So we have the data chart, and then here we use the chart areas, and then that will be the 0th, and then first we do something with the axis x, and for example is started from 0 and false, because what if we in case we get negative number, so this is good for that. And then I cheat a little bit to be quicker. So again axis x, and this is just some fancy graphics. So we put this or set this to 0, and then we do the same with the y-axis. So there will be no grids, this means. Okay, no grids, if I remember correctly. Then we can name the axis. So title, and then let's call it x-axis, and then just put this here, and we do this with the axis y. as well, sorry. We can enable the axis as well. So this should be axis enabled. Oh, that's true. In fact, we can add this. So I added system.windows.forms data visualization charting to the program, and then we do the same here as well with the axis Y. Axis enabled, that true. And one very useful stuff is that we make auto scroll, so the chart will scroll itself. And now we create the first series for the chart. So oops, sorry again. And here we give a name, and let's call it channel 1, for example. Then we give a color, and then let's make it black, for example. And then we give a type to the chart, so what kind of stuff we want to use. You can see we have a lot of things, but if we want to quickly visualize data, then I recommend you fast point or fast line. So here we use, in this example, fast line, and then we index the values. True. And almost done. Like this. And we add this. Alright, so we have our chart here. In fact, you can like copy paste this selected part and do like this and call it series 2 and series 2. So now you will have two data, and let's make it 2. So we will use this later, but you can see that basically you copy paste this part. So if you have, let's say, 4 channels, so you use the 4 or more AD converters of the Arduino, and you read the data from those, and you want to visualize them. So you basically just select this part that I selected, select this part, copy paste it, and then you rename the variables. So series, and then the next should be series 2, or you can give other name to this, but make it consistent. So if you create one series, then you have to add it, and then you have to create the second one, and you have to add it, and so on and so on. And here you can make secondary axis and whatever, but I write here that check the MSD and documentation, because you will find like hundreds of these kind of things that you can modify. So finally we have chart, so we have to go back to this processing data part. So first of all we left it here, so we have to plot the data. So if you remember, we had the series, and we had the channel 1, which was here. Now let's remove this space. So channel 1, you have to use the name, preferably. And then we add the points. So add x, y. And then which we want to use is basically this. So this will be our x value. And then we add the split 2, which is the y value. And we can recalculate the axis after we add. That will make sure that the scale will be, or the grid will be scaled, or the chart will be scaled according to the data. So for example, you get data like 1, 2, 3, and you immediately get 100, then the scale will adjust to your data. So data chart, chart areas, and then we use the 0 chart area, so that we create it here, and recalculate axis scale. So this is done so far. So we have this part done. We can plot the first data. So I think we can try it, because yes, we created this part, and we have to implement the save to file, but I will do that after we make sure that we can use the chart. So let's check if I haven't messed it up. So it works so far, and you can see that we have the 2 channels. So my Arduino is already connected, and as it was in the previous video, COM6 is our port. So we are connected, and we immediately go for the option D, because if you remember, that will send us these 3 data. So let's start it. And now you can see that on the x-axis we get the numbers 1, 2, 3, and on the y-axis we get the millis, so that's the CPU time, and you can see that basically these data, or the first 2 parts of the data, is getting like plotted on this chart. And since it's linear, of course we get a linear curve or linear line here. So as you can see, it's very, very simple to visualize your data, and we can stop this. So now it stopped, and we can add the other chart, so this third column, just to see what happens. So we close this, and now to be on the safe side, I remove and reconnect my Arduino. So that's what you heard. So we duplicate this, but we add the channel 2. So basically this is column 1 and column 2, and this is column 1, so they share the same x-axis, but this is column 3, and we have to work accordingly. So this is done. So now what I did, I just simply added the second data that we created here, basically the second series, and that should be a red line. So we start again. We are here, we connect again, and then press D and send it. And you see that we have 2 lines, and it's increasing in every second. So basically we have the time at every second since we started the code, and the red line is 3 times larger than the black line. So you can see it on the data as well. So for example, we have 4,000 and we have 12,000 here, and you can see that they are increasing nicely. So then you can do like sending the milliseconds, for example, that is measuring the elapsed time, and you send the temperature as well, and you plot it, and then you can follow the temperature, and you can leave it on and measure the temperature of your room overnight, for example. That's a fun thing to do. So we are done with this part. So we stop, and you can see that this is very nice. But we are not done yet, because we have to save the data. So what we do here is we go back to this part, and we can make a very simple thing. So let's create a variable which I think we should call it a string. So private string and f output, so like file output. So what we do with this f output is that will be our temporary holder for the data. So we say that okay, handle the output. So the f output is basically split one, and we convert it to string, and then we add a tab, and let me copy paste this part, and then we add the split 2, if I manage to. And we convert it to string, and then we add the split 3, and we convert it to string, and here we make a line break. If I manage to press the right, so basically we convert back the data into this part. In fact, I'm pretty sure that we can also do like this. Because this is already a string, should be. Now it's a string. And then we just print it. So we use the stream writer, and something should be added. So we add this IO here, because we will write files. So we use the stream writer, and yeah, whatever we use here, and we try to append the text sorry, and let's just give something output file .txt, and we write this f output. So this is done, and we would like to make use of this. And if you remember, the name of this was file saving checkbox. So we go here and we make an if file saving checkbox dot checked is true, Then we do this part below. Oops. So we created this condition here, and then what happens is that this stream writer will write this f output variable, or the value of the variable, into our output file.txt text file. And then we have to make sure that everything is correct. So these are okay. And maybe we will have some problem with the split, because it's a string with string array with 3 parts. So maybe for now I would like to try the other method, which is more clean. So check. We checked it. We selected the COM6. We connected, and then we go, and this will be enough. So this problem was from this previous test, where I tried to test it with the other split, and that failed because I messed it up. So we have to make sure that we select the actual value that we want to print. But here, if we print the components, then we get back the exact same values as we have it on the screen. So this was simple, and we have everything now, so we can save the file in a very simple method, and file saving, and we can use the chart as well. So I think this was all for this part of the video, and maybe there will be a next video where I will make more functions for the chart or for the processing of the data. But I think if you follow these 3 videos and check the MSDN documentation and check some other tutorials as well, then you will be able to expand these functions and expand the possibilities that you can do. So I think this was all, and I hope you learned something, and see you in the next video.